black holes have long been among the most fascinating and mysterious objects in the universe. These dark, invisible points of intense gravity seem to defy the very laws of physics, leaving us with endless questions about their true nature and the forces they contain. Their presence has sparked curiosity, and the more we learn about them, the more we realize just how little we really know. There's a reason why black holes have such a grip on our imaginations. They represent both the simplest and most complicated aspects of nature. As we continue to peer deeper into the cosmos, we're learning that black holes aren't just extraordinary objects, they might also hold the key to some of the most profound secrets of the universe. The Hubble Space Telescope, which has been orbiting Earth for decades, has been one of the most essential tools in the search for answers about black holes. Many of us might have forgotten about this iconic instrument, or think that it is no longer active, but Hubble is still scanning the universe every day. It continues to reveal new phenomena, expanding our understanding of the cosmos. And recently, Hubble has landed a completely unexpected discovery. It has succeeded in uncovering a new type of black hole, intermediate black holes, or IMBHs for short. For years, scientists were aware of two types of black holes, stellar black holes and supermassive black holes. Stellar black holes form from the collapse of massive stars, their gravitational pull growing so strong that nothing, not even light, can escape their grasp. Supermassive black holes, on the other hand, are found at the centers of galaxies and can be millions, or even billions, of times more massive than our Sun. These two categories seem to represent the complete range of black holes, with nothing in between. But the discovery of intermediate black holes changes that perception entirely, showing us that the cosmic landscape is far more complex than we previously thought. Intermediate black holes, as their name suggests, sit between stellar and supermassive black holes in terms of mass. These black holes can have masses anywhere from a few hundred to a few thousand times that of the Sun, making them significantly larger than the typical stellar black holes, but still far smaller than the largest supermassive black holes. Their existence raises a host of new questions about how black holes form and evolve. Could intermediate black holes be an essential part of the process by which supermassive black holes are created? Could they play a role in the formation and structure of galaxies? These are just a few of the questions scientists are grappling with as they study these new cosmic objects. The discovery of intermediate black holes is groundbreaking because their existence has only recently been confirmed. For years, their presence had been hypothesized based on theoretical models, but without concrete evidence, many scientists remained skeptical. That is, until researchers began to analyze the star cluster Messier 4, located about 7,000 light-years away from Earth. In this cluster, astronomers observed the movement patterns of stars that could only be explained by the presence of a particularly massive and compact object, an intermediate black hole. The stars in the cluster were behaving in ways that couldn't be accounted for by the usual gravitational influences, leading scientists to conclude that something far more massive than the surrounding stars was exerting a gravitational pull on them. What's truly remarkable about this discovery is how it was made. Astronomers were able to pinpoint the presence of this black hole by carefully analyzing the movements of the stars in the Messier 4 cluster. By using data from the Hubble Space Telescope and the European Space Agency's Gaia mission, they were able to track the stars' positions and velocities with astonishing precision. This allowed them to infer the presence of a black hole with a mass of around 800 times that of the Sun, significantly larger than small stellar black holes, which typically range in mass from about 3 to 20 times the Sun's mass, but much smaller than supermassive black holes, which can weigh billions of times more than the Sun. This discovery marks a turning point in our understanding of black holes and their role in the universe. The fact that intermediate black holes exist suggests that the processes that lead to the formation of black holes are more varied and complex than we thought. Until now, scientists had only speculated about the existence of black holes in this intermediate mass range, but now we have solid evidence that they are real and that they may be crucial players in the formation and evolution of galaxies. In many ways, black holes are like cosmic sculptors. Their immense gravitational pull can shape the structures around them, influencing the formation of galaxies and stars. The beauty and complexity of galaxies, with their swirling arms and elegant spirals, are likely the result of the gravitational influence of supermassive black holes at their centers. These black holes don't just sit passively at the heart of galaxies, they actively shape the galaxies around them. It's believed that black holes play a key role in regulating the rate of star formation in galaxies. By pulling in gas and dust from their surroundings, black holes can trigger the creation of new stars, but they can also suppress star formation by expelling matter in powerful jets. It's this interplay between the black holes and the galaxies they inhabit that makes the universe so dynamic and ever-changing. The discovery of intermediate black holes adds another layer of complexity to this picture. These objects, with masses lying between stellar and supermassive black holes, may represent an important missing link in our understanding of black hole formation and their relationship to the larger structures in the universe. One possibility is that intermediate black holes might be the result of smaller stellar black holes merging together, creating a black hole of intermediate mass. Another theory suggests that they could be the products of the collapse of massive clouds of gas and dust in the early universe, an entirely different process from the one that forms stellar and supermassive black holes. Regardless of how they form, the presence of intermediate black holes raises important questions about the evolution of galaxies and the forces at play within them. For instance, how do these intermediate black holes influence the stars and gas around them? Do they play a role in shaping the structure of galaxies? Scientists are still working to answer these questions, but what is clear is that black holes, of all sizes, are much more than just cosmic vacuum cleaners. They are active participants in the ongoing dance of the universe, shaping the galaxies, stars, and nebulae that we see around us. To study black holes, especially intermediate black holes, astronomers rely on a variety of advanced observational techniques. Since black holes themselves cannot be seen directly, scientists use indirect methods to infer their presence and learn about their properties. One of the most important tools in this process is spectroscopy, which allows astronomers to analyze the radiation emitted by objects in the vicinity of black holes. By studying the light and gases emitted by stars and other objects orbiting a black hole, scientists can determine the mass of the black hole and map its position in space. This method has provided much of our current knowledge about the mass and location of both stellar and supermassive black holes. Another important technique for studying black holes, particularly intermediate black holes, is gravitational lensing. Gravitational lensing occurs when the gravity of a massive object, like a black hole, bends the light from more distant objects behind it. This effect can cause the light to appear distorted and magnified, creating what looks like a lens in space. When an intermediate black hole passes in front of a distant light source, its gravitational pull can cause the light to bend, making the background object appear brighter and distorted. By analyzing these distortions, astronomers can infer the mass and position of the black hole responsible for the lensing effect. As technology advances, astronomers are gaining more and more tools to study black holes. While the Hubble Space Telescope has been instrumental in detecting and studying black holes, the newly launched James Webb Space Telescope, JWST, and the Chandra X-ray Observatory are taking things to the next level. These powerful telescopes offer incredibly high resolution and sensitivity, allowing astronomers to observe the faintest details in the surroundings of black holes. The JWST, with its infrared capabilities, is particularly well suited for studying the environments around supermassive black holes, while Chandra's X-ray vision helps scientists observe the high-energy processes taking place near black holes. In addition to these telescopes, the Gaia mission is another invaluable tool in the search for intermediate black holes. The Gaia spacecraft is mapping the positions and movements of billions of stars in our galaxy with unprecedented accuracy. By studying the motion of stars and star clusters, scientists can detect the gravitational influence of intermediate black holes. The precise data from Gaia can help astronomers track the movements of stars and other objects in the vicinity of an intermediate black hole, providing important clues about the black hole's mass, location, and influence on its environment. Theoretical astrophysicists are also working hard to understand the dynamics of black holes through the use of numerical simulations. By simulating the interactions between stars and black holes and star clusters, scientists can gain insights into how intermediate black holes form and evolve. These simulations help astronomers test their theories about black hole formation and provide a framework for interpreting the data gathered by telescopes. As we continue to collect more data, these models will become increasingly accurate, allowing us to better understand the role of black holes in the cosmic order. Despite the tremendous progress we've made in studying black holes, there are still many questions that remain unanswered. One of the most intriguing questions is how black holes influence the formation of galaxies. We know that supermassive black holes are located at the centers of galaxies, but how did they get there? How did they form in the first place, and what role did they play in the early evolution of galaxies? Some of the latest discoveries, such as the ultramassive black hole found by the James Webb Space Telescope, have thrown our previous theories into question. This black hole, which existed only 570 million years after the Big Bang, is 10 million times the mass of the Sun, far too large to have formed through the usual processes of black hole growth. Could black holes have formed much earlier than we thought? Could they have played a role in the formation of galaxies from the very beginning? One theory, proposed by the renowned physicist Sir Roger Penrose, offers an intriguing solution to some of these questions. Penrose's theory suggests that the universe might be cyclical, with each cycle beginning with the formation of a new universe after the collapse of the previous one. In this theory, black holes play a key role in the process. At the end of each cycle, the massive black holes at the centers of galaxies would eventually consume all the matter in the universe, causing the universe to collapse in on itself. But once the black holes have consumed everything, they would evaporate, and a new universe would be born. In this way, black holes could act as portals to the rebirth of the universe, allowing the cycle of creation and destruction to continue indefinitely. As we continue to study black holes and push the boundaries of our knowledge, it's clear that these mysterious objects are far more than just strange anomalies in space. They are the building blocks of galaxies, the engines of cosmic evolution, and possibly even the gateways to understanding the very nature of the universe itself. With the advent of new technologies like quantum computers and artificial intelligence, we may one day be able to unlock the deepest secrets of black holes, revealing the mysteries of the cosmos and answering the age-old questions about the creation of the universe. Until then, the study of black holes will remain one of the most exciting and rewarding pursuits in modern science.